Okay, so yesterday we started our logarithm unit. We are going to keep going. As a warm-up, turn to page 9, and I would like you to do numbers 1 through 6. So in your tables, we're going to pause the video. You do numbers 1 through 6, and then we will check our answers. Okay, for number 1, you're going to say 7 to what power is 1? And the what power has to be 0. The only way to have an outcome of 1 is to have an exponent of 0. For 2 to what power is 16? So I'm thinking to myself, 2 times itself how many times? That's 4. For 3 to what power is 1/9? I'm going to make my bases the same for that. So I'm going to change my 1/9. The 9 is 3 squared. But then to move that out of the denominator, to move that term out of the denominator, I have to make my exponent negative. So the what power is -2. All right, for 4, this one's tricky. 1/3 to what power is 27? So I want both sides to be 3 to an exponent. If I can make both sides 3 to an exponent, I can get my log answer. So I'm going to take my 1/3 and say that's 3 to the -1 to move the 3 from the denominator. And 27 is 3 cubed. So -w equals 3 from your exponents. Divide both sides by -1, and so our logarithm equals -3. Okay, for 5, 4 to what power is 2? Well, I can make 4 a base of 2. That's 2 squared. So we can multiply those exponents together. So 2w is going to equal the exponent on the right-hand side of 1. So the what power is 1/2. And then your last one, 16 to what power is 8? Let's see. So 16 and 8 can both be made into a base of 2. So 16 is 2 to the 4th, and 8 is 2 to the 3rd. So I've got 4w equals 3. Divide by 4. So the what power, this logarithm is 3/4. Okay, so that's some good review of yesterday. What we're going to move on to today is turn to page 12 in your packet. And we've got some expansion rules of logarithms. And you do have to memorize these 3 rules. We're going to practice them a bunch on this page. And that's exactly what your homework is going to have you practice as well. So remember, what you're taking the log of is called the argument. So when the argument is a product, when it's multiplied, x times y, I can expand that log to 2 different logs with addition in between. So when the argument is multiplied, we can expand to addition. When the argument is divided, we can expand to 2 different logs with subtraction in between, with the denominator of the argument being the second term. And then when your argument has an exponent, when you have x to a power or a number to a power, what the log can do is that exponent can move and become the coefficient of the log. Like this k can come to the front, and that's how it's k times log base x. So let's look at number 1. We've got log base 2 of 9 to the 5th. So what we're going to do is I say, oh, look, I've got a 9 to the 5th. That's this x to the k. So this 5 can become the coefficient here. and I leave the 9 in the argument. So then let's look at 3. See how we have division, 19 divided by 2? So that's this middle rule. The x is 19 and the y is 2. So I can separate that to 2 logs with subtraction. So that's going to be log base 5 of 19 minus log base 5 of 2. Let's jump over here to 4. So log base 2 of 6a. So 6 is multiplied by a. That's 6 times a. So I can use the top log rule. I can expand this to log base 2 of 6 plus log base 2 of a. Okay, we're going to pause the video. I want you to try 5 through 8. We're going to skip 2. So try 5 through 8 on this page, check with your tables, and then we will go over the answers. And then we're going to try some harder ones at the bottom. Okay, so for number 5, you should have had log base 3 of x plus log base 3 of y, because the argument is x times y, so I can expand that with addition. For 6, our argument is divided, so you've got log base 5 of a minus log base 5 of 3. 7 is back to a multiplied argument, so that's log base 3 of 5 plus log base 3 of y. And then for 8, we have an exponent, so that can move to be a coefficient, and we get 10 log base 3 of a. All right, so here at the bottom, we're going to expand some more. Let's go to number 10. All right, number 10, we've got a divided by b all to the 5th. So the order of operations matters. The whole argument is a 5th power, so I'm going to start by moving the 5 to the numerator. I'm sorry, the 5 to be the coefficient, excuse me. So this 5 can move down based on the last property at the top. But then we have to keep going. So now I've got a divided by b. So I'm going to go one more step and say that's 5. You need the parenthesis. And it's going to be log base 2 of a minus log base 2 of b. If you really wanted, you could distribute the 5 and say 5 log base 2a minus 5 log base 2b, but you don't have to. As long as you have those parentheses, it shows the 5 applied to both the a and the b back in the beginning when we started. Okay, let's do 11. So for number 11, we've got log base 5 square root of x to the 5th y. So your first thing to do is we have to write the square root as an exponent. So we have that whole power functions unit. So the square root as an exponent is the 1/2 exponent. And we can skip 13, so we'll just take some space as we go down. So now that we have this exponent here, we can make that become the coefficient. Then I'm going to expand this argument. I'm actually going to use some separate paper. That's going to be messy. So when you have x to the 5th y, that's multiplication. So that's log base 5 of x to the 5th plus log base 5 of y. Then we have one more step. We're not quite done. This exponent can now become the coefficient of that first log. So we have 1/2 multiplied by 5 log base 5x plus log base 5y. You could distribute the half. You don't have to. personal preference. All right, let's try 12. I'm going to take care of this exponent first and bring that to the front to make it a coefficient. And then we've got a combination of multiplying and dividing. So we know when part of the argument is multiplied, we can expand with addition like we did. And then the part that's divided will be after the subtraction. So I'm going to do all of that in one step. I'm going to have 3 logarithms. I'm going to have log base 5 of x plus log base 5 of y minus log base 5 of z. You could distribute the 8. You don't have to. Let's see, what other one do I want to do? Ooh, let's do 17. We got some space at the bottom there. We're going to do 17 and 18, and then we'll do our homework. Okay, so for 17, actually, let's pause the video. You try 17. See as far expanded as you can get. So I got log base 2 of 4 plus log base 2 of a minus log base 2 of 5. But if that was your final answer, you're not quite done. There's one little extra step here. Log base 2 of 4, we can evaluate that. 2 to what power is 4? That's 2. So if one of your log terms can be evaluated, you should simplify it, just like you would never leave the square root of 9 in an answer. The square root of 9 is 3. You simplify when possible. So you should simplify the log when possible. I didn't simplify the log base 2 of 5 because 2 to what power is 5? It's a no calculator unit. I can't do that. There's no value, there's no integer value or rational value that I can raise 2 to be, raise 2 to get a value of 5. All right, let's try 18. First, we're gonna make the cube root an exponent of 1/3. Okay, so we're gonna pause the video here. You try the rest of 18. Check with each other. So the first step, you gotta bring the 1/3 to be the coefficient. Then I'm gonna expand my log with addition because the argument is multiplied. And we've got one more exponent that can move. And your final answer should either be 1/3 with this parentheses, 2 log base 2 of x plus log base 2 of a. If you wanted to multiply the 1/3 to each term, you'd get 2/3 log base 2x plus 1/3 log base 2a. Either answer is right. I would take either of these. The quiz is completely free response. You would have to show your work. So either of the answers is fine. Okay, so your practice and your homework is page 13 to 14, 13 to 30 all. So you're gonna skip this whole top part. So start down here with number 13. All the answers are in Drive, so you can check yourself. So check your answers.